In the black stillness of interstellar night, a planet drifts unseen. It circles its parent star in silence. Its oceans, if they exist, untroubled by any witness. Its skies never pierced by an eye. For billions of years it has turned, anonymous, forgotten by all but gravity, yet across the void. Faint whispers have begun to cross the darkness. They arrive not as sound, but as light, photons stretched and thinned by distance, carrying secrets hidden in the spectrum of a star through the golden mirrors of the James Webb Space Telescope. Those secrets unfold like scripture written in starlight molecules, reveal themselves in fragile patterns. Oxygen and methane, water vapor and carbon dioxide, an improbable balance, a disequilibrium that nature rarely sustains without help. The telescope becomes less an instrument, more an oracle, a single eye opened in the abyss, able to see what no human eye ever could. What does it mean when probability stops being abstraction and becomes near certainty? What does it mean when numbers whisper not of theory, but of presence somewhere, perhaps beneath alien clouds? Something may be breathing the silence of the universe, long mistaken for emptiness, begins to fracture. This is not the end of the mystery, it is its beginning. A hidden world has stirred, and in its faint spectral trace, humanity confronts the most profound question of all. Are we alone? Or has the universe always been alive, waiting for us to finally listen? If you are new here, join the journey. Like, subscribe, and let's begin. In the frozen silence beyond Earth's atmosphere, a golden eye was opened to the cosmos. It was not made of flesh or bone, but of beryllium and mirrors. It was not set in a skull, but in the cold lattice of carbon fiber trusses. And yet it could see more clearly than any creature that had ever stared into the heavens. This was the James Webb Space Telescope, a machine designed not to look at the stars as they appear, but as they were, to collect the faintest whispers of light stretched thin across billions of years, to trace the fire of creation back to its first embers, and to search among the countless shadows of distant worlds for the glow of breath, of clouds, of oceans, of life. Its mirrors gleamed like shields of the sun, 18 hexagons of polished gold. Together, they formed a single surface, 6.5 meters across. The largest mirror ever launched into space, large enough to gather the dimmest, photons traveling since the dawn of galaxies, but delicate enough to split those photons into their hidden colors, their spectral fingerprints, where Hubble had seen the universe in ultraviolet and visible light. Like the vision of human eyes raised to a higher clarity, Webb was built for the invisible infrared light. The heat of stars swaddled in dust, the warmth of planets circling other suns, the stretched relic glow of the Big Bang itself. Infrared reveals what dust obscures, what distance dims, what time has hidden in that spectrum. The universe is transparent, and worlds announce themselves to keep this vision pure. Webb was armored against its own warmth. A sunshield, thin as a razor, yet broad as a tennis court, unfurled like a silken sail against the sun 5 layers of Captain film, each a mirror to reflect away heat, separating the telescope from its own star-bright source of blindness. Behind those veils, the mirrors chilled to just above absolute zero. Only in that frozen silence could it distinguish the warmth of a planet, light years away from the faint radiation of its own skin, launched on Christmas Day 2021. It was not merely an instrument, it was a promise. 30 years in the making, an engineering gamble so precarious it carried over 300 single points of failure. Any one of them could have left it blind, stranded, or broken. Yet each latch closed, each panel locked, each sail stretched, each mirror unfolded, like the petals of a flower blooming in the void. A ritual of patience that turned machinery into an eye. When it finally opened and looked outward, it was not just galaxies that came into focus. It was the possibility of other skies, other seas, other biologies written in alien light. For the first time, humanity held a tool sharp enough to read the chemical breath of distant atmospheres. The method was simple in description but profound in consequence. As a planet drifted across the face of its star, some of the starlight passed through its atmosphere before reaching Webb's mirrors. That light was changed, Atoms and molecules in the alien sky absorb specific wavelengths, leaving behind patterns, spectral lines, chemical shadows. By splitting the star's light into its rainbow, Webb could see the fingerprints of water vapor, methane, carbon dioxide, or oxygen etched within. It was like listening to a voice carried on the wind, not hearing the words, but sensing the breath behind them. This technique, transit spectroscopy, had been imagined for decades. Hints of atmospheres had been teased from Hubble and from ground-based telescopes. But Webb was the first to wield the sensitivity required to make them clear. Undeniable, vivid, not just to guess, but to measure, to weigh the skies of worlds, orbiting suns, hundreds of trillions of kilometers away. The first demonstration came swiftly. Webb turned its gaze to WASP 96b, a hot gas giant circling a star nearly 1,200 light-years distant. When its spectrum was revealed, the lines were unmistakable. Water vapor, arching in a broad band, traced across the chart clouds and hazes, once invisible, now declared themselves in the mathematics of light. It was a triumph, a world revealed not by images, but by chemistry. And yet, this was only the beginning. For if clouds and vapors could be seen on a bloated giant far away, then oceans and storms might one day be detected on smaller, Earth-like worlds. The promise of Webb was not only to study the ancient light of galaxies, but to weigh the air of planets that might host life. To see the invisible was to trespass into realms where human imagination had always lingered, but where evidence had always eluded. Every culture had stared into the night and wondered if life breathed on other stars. Webb's mission was to answer not with myth, but with spectra, with data so sharp it could cut through centuries of silence. The telescope itself became a metaphor, an eye without a face, a mirror without a body, placed far beyond the reach of Earth's atmosphere and noise. In its golden surface, humanity's longing was reflected, the desire to know, to confirm, to listen. It was not looking for stars, for they had been known since the first fires. It was looking for echoes of ourselves, refracted in alien skies. In this way, Webb's first planetary atmospheres were not just measurements, they were thresholds, the first footsteps into a darkness that might not be empty, the first syllables in a language the cosmos had been speaking for billions of years, now finally heard. And so, the James Webb Space Telescope became the eye that sees the invisible, not an end, but a beginning. Not just a machine, but a mirror held up to the universe itself. Through its gaze, the cosmos is no longer silent. It is whispering. In the black ocean of night, there are stars that flicker faintly, stars whose glow is little more than the memory of a candle drifting in distance. Among these fragile points of light, one star in particular drew the gaze of the James Webb Space Telescope. It was unremarkable to the naked eye, dim enough to vanish into the dust of the Milky Way, yet it held in its embrace a planet that would test the very boundaries of human certainty. The star was a quiet red dwarf, cooler and smaller than the Sun. Such stars are the most common in the galaxy, making up nearly 3/4 of all stellar populations. They burn dimly, slowly, and for trillions of years. Their longevity makes them ideal hosts for worlds where biology might take root, for they grant their planets aeons of steady light and warmth. This star lay just beyond 30 light-years away, nestled in the faint sprawl of the constellation Aquarius. A distance close in cosmic terms, a neighbor by galactic standards. For Webb, orbiting far beyond the Moon, it was a reachable target, a flame faint enough to be studied, steady enough to reveal its hidden worlds. When Webb turned its golden mirrors toward the star, its task was simple in principle and immense in significance: to watch patiently as a planet passed before its sun and to catch the faint dip in brightness. Each transit, a fraction of a percent in light lost, would be the planet's shadow, speaking across the void. And as the star's glow passed through the alien atmosphere, The light would carry the imprint of gases unseen, a spectrum coded in silence. The first data arrived as streams of numbers, voltage counts from detectors chilled to near absolute zero. To human eyes, they were only curves and graphs, not yet skies and oceans. The starlight dimmed, precisely as expected, in regular rhythm. The planet, an Earth-sized world orbiting close to its parent star, announced its presence not with an image, but with the mathematics of light. Its orbital period, measured in mere days, its path so tight it clung to the warmth of its sun. And yet, nestled within that orbit, was a zone where liquid water could, in theory, endure a habitable edge, neither too scorched nor too frozen. Precarious, but possible. The light curve was the first whisper, a dip repeating in cycles, the signal of a world unseen but real. Then came the second, the absorption lines etched faintly into the star's spectrum during each transit, lines no longer belonging solely to the star, but to the planet's air. At first, it was routine, the kind of analysis astronomers had performed many times before. Check for water vapor, for carbon dioxide, for methane, the usual suspects of atmospheric chemistry. Often, the result was emptiness, the flat silence of a world too barren or too clouded to reveal its breath. But here, the silence broke. The first traces showed imbalance, a pattern that did not settle easily into geology or chemistry alone. Molecules in strange ratios, hints of reactions that whispered of biology rather than barren stone. The scientists who gathered around the raw spectra were cautious. Every step required rigor. Every claim weighed against error and noise. Red dwarfs are turbulent hosts, often flaring with radiation that can mimic signals or strip atmospheres entirely. Cloud decks can disguise absorption lines. Hazes can distort clarity. The temptation was to dismiss, to search for mundane explanations, but the lines remained. They sharpened with each transit, as Webb's instruments caught more light, more whispers, more signatures, etched across the rainbow of the alien sky. What they were seeing could not yet be called life, not in certainty, but they were the kind of patterns that scientists had long dreamed of detecting. For decades, astrobiology had built its framework around the idea of biosignatures, clues written not in fossils or photographs, but in chemistry, the imbalance of gases that, on Earth, are only sustained by biology. On Earth, oxygen and methane coexist only because life renews them. Without photosynthesis, oxygen would vanish into rock within a few million years. Without microbes, methane would dissolve into carbon dioxide. It is their simultaneous presence that signals something active, something alive. To detect such a combination elsewhere would be to hear a planetary heartbeat, and so the notion of biosignatures became the guiding star of exoplanet science. Water vapor to indicate seas, oxygen to hint at photosynthesis, methane as a possible echo of microbes' carbon dioxide to anchor atmospheres and climates. Even subtler signs, chlorophyll-like pigments reflecting light, or seasonal variations in gases, were imagined as whispers of distant ecologies. Here, in the faint light of this red dwarf's planet, those whispers were rising into words. Not yet a sentence, not yet a declaration, but more than silent spectra that hinted at water vapor in combination with methane equilibrium broken, balance undone, chemistry leaning toward the improbable without some hand of biology at work. For the astronomers, it was a moment suspended between awe and doubt. The numbers suggested something extraordinary, yet science demands skepticism as its first response instrument. Error, stellar contamination, miscalibrated models. All were considered, tested, and rechecked. But still, the signals returned. Still, the atmosphere spoke. It was as if the universe itself had chosen this faint, unremarkable star to breathe a message across the gulf of space. Not a message written in language or sound, but in molecules. The planet had not declared life, but it had raised the probability high enough that silence alone was no longer the most likely answer. The first whispers from the dark had been heard, and with them, the weight of an ancient question shifted not, "Are we alone?" but "How could we ever have thought so?" For in the spectrum of a star's dim light, refracted through a veil of alien sky, there now stood the possibility that Earth was not singular, that life, in some form, might already be breathing elsewhere, waiting for the patience of golden mirrors to make it known. And so the chapter of silence began to close, and the chapter of whispers began to open. Whispers that would soon grow louder, more defined, more challenging to everything once thought about life, planets, and the solitude of humankind. The James Webb Space Telescope had listened, and the dark had spoken, not in certainty, but in probability so high it bent disbelief. And in those faint absorption lines lay the first suggestion of a living universe, waiting just beyond reach. In science, numbers are not poetry, yet sometimes they strike like revelation. They are supposed to be neutral, dispassionate, the distilled essence of measurement. But there are moments when numbers break the boundary between calculation and wonder, when digits and decimals carry the force of a cosmic announcement. For decades, exoplanet science has lived in the language of probability, each discovery expressed as likelihoods, as models woven from incomplete light. The chance that a planet lies within its star's habitable zone, the probability that its orbit is stable, its air intact, its surface temperate from these fragments. Scientists built statistical frameworks, fragile towers of inference that suggested the galaxy must be abundant with worlds where water could flow and life might emerge. At first, these models were cautious. In the early 1990s, when the first exoplanets were confirmed, many were giants pressed tight against their stars. Hot Jupiters, too scorched and turbulent for biology. The odds of finding Earth-like conditions seemed remote, almost fanciful. But as the catalogues grew into the thousands, patterns emerged. Planets were not rare. They were the rule. Every star seemed to carry companions. Many in orbits where liquid water could exist, probabilities climbed, and a quiet confidence spread that life, too, might not be rare. Still, these were only estimates, drawn from the vast silence of unmeasured worlds. No telescope had ever placed a number beside a single planet that came close to certainty until Webb, when the James Webb Space Telescope gathered its first full atmospheric spectrum of the faint red dwarf planet. The models were recalculated instead of vague hints. There were signatures, overlapping gases in disequilibrium, water vapor braided with methane, a chemistry that on Earth has no stable explanation without biology continually renewing it. The algorithms ran, cross-checking known geological and chemical pathways. They produced probabilities not in the tentative range of 20 or 40, or even 60%. They produced a figure that startled even the scientists who built them. 99.7%. The probability that this planet's conditions required biology rather than geology. Not a certainty, not proof, but a weight so immense it collapsed the gap between speculation and belief. In statistics, 3 sigma significance is the border where chance gives way to confidence. In particle physics, such a threshold hints at discovery for exoplanet science. 99.7% was a thunderclap. The number carried both beauty and terror. It whispered that life, long thought improbable beyond Earth, might in fact be commonplace, waiting only for eyes keen enough to see it. Yet it also demanded scrutiny, for science is allergic to certainty born too quickly. Could stellar flares have forged these gases? Could hidden chemistry, unknown to Earth, mimic the fingerprints of biology? Could Webb's instruments themselves have whispered illusions? In observatories and laboratories, disbelief mingled with exhilaration. Some astronomers stared at the data in silence, reluctant to even speak the figure aloud, as though naming it might dissolve its power. Others felt a surge of joy, of vindication, that lifetimes of searching might finally have borne fruit, and others still hesitated, reminding colleagues that science is not revelation but process, that numbers can dazzle even when they mislead. Yet the figure could not be erased. In papers drafted and shared across preprint archives, in conferences whispered with excitement, the 99.7% recurred. It was not proof, but it was perilously close to conviction. The tension was not only scientific but psychological, for humanity has long been trained to live with uncertainty. The possibility of life elsewhere had always floated in the realm of maybe, safe in its distance. To imagine that the universe was alive was a dream that could be entertained without consequence, but almost surely is a different weight. It reshapes the imagination it presses upon the mind with inevitability. If the probability is that high here, then it must be high elsewhere. If life is likely on one world, it is likely on millions. The cosmos, once silent, becomes suddenly crowded in thought, a place not of solitude but of unseen company. The shock of numbers is not just the number itself, but what it forces the mind to confront for centuries. Earth has been the single datum, the only known living planet. All arguments rested on this one fragile example, but now another data point rose from the dark, almost certainly alive, and with it, the entire weight of human self-understanding shifted. The language of science recoiled, cautious, unwilling to declare discovery. Astrobiologists spoke in tempered phrases: high confidence, strong biosignature candidates, anomalous chemistry. For in the discipline of science, words are fragile currencies. To say too much risks collapse. To claim too early risks ruin, but behind the restraint, the human element surged, the recognition that a number, precise and merciless, had brought humanity closer to an answer than any myth or philosophy had ever dared, and so the 99.7% became more than probability. It became a threshold of belief. It was the moment when silence broke, not with sound, but with digits. It was the moment when astronomy stepped out of shadows and declared that the search for life was no longer a question without data, but a mystery with direction, with weight, with odds that tilted toward the living. The shock of numbers lingered because it forced a choice to remain cautious, bound to skepticism, or to allow the possibility that the universe was already alive around us. The scientists could not yet declare life found, but in their quiet moments, staring at the spectra that glowed on their screens, many knew that they were seeing not just chemistry, not just light, but the first evidence that humanity's solitude might finally be ending. And in that silence, in that number, a profound truth whispered, that perhaps the cosmos had never been waiting to be filled with life. Perhaps it had always been alive, and only now had we built an eye keen enough to recognize it. The planet itself could not be seen directly. It was a shadow, a faint interruption in the brightness of its star, a silhouette without detail. Yet in that passing shadow lay the possibility of revelation. When the James Webb Space Telescope turned its golden eye toward the system, it was not the planet's shape that mattered, but the veil around it, a thin sheath of gases clinging to rock and water, invisible to the human eye but luminous in infrared. Atmospheres are archives. They hold the record of a planet's chemistry, its weather, its hidden processes. They can speak of oceans unseen, of volcanoes still burning, or of forests that breathe without witness. For Webb, the method was simple in principle, but profound in consequence. As the planet passed across the star, a fraction of the starlight filtered through its air. That light, stretched into its spectrum, carried signatures, absorption lines, each a fingerprint of a molecule suspended in the alien sky. The first data revealed water vapor, not a mere trace, but a presence that suggested clouds, perhaps rain. Alongside it was carbon dioxide, the familiar gas that, on Earth, binds climate and life in delicate balance. Then came methane, faint but undeniable. And finally, the element that set hearts racing, oxygen. Individually, none of these gases guaranteed biology. Water vapor could rise from boiling oceans, carbon dioxide from volcanic stone. Methane might seep from geological vents, oxygen from photochemical reactions. But together, they formed an impossible harmony. On Earth, these gases exist in tension. Oxygen consumes methane. Carbon dioxide and water cycle through living processes, locked in exchange between soil, air, and breath. To find them coexisting in the same sky in measurable abundance suggested something more than geology. It suggested equilibrium born of life, a disequilibrium that could not last without constant renewal. This was the essence of a biosignature, not the presence of a single chemical, but the unlikely symphony of many. The planet's air was not silent. It was writing in light, a coded language of chemistry, and Webb had become its translator. Disequilibrium had always been the key. When James Lovelock, decades earlier, proposed his Gaia hypothesis, He had pointed to Earth's atmosphere as its most persuasive argument. If Earth were lifeless, its skies would be inert, dominated by carbon dioxide like Mars, or smothered by sulfur like Venus. Instead, it was filled with oxygen, unstable yet sustained, balanced by the invisible respiration of countless organisms. Earth's atmosphere was alive because it could not be otherwise. Now another world seemed to speak the same way. Scientists had been misled before. Mars had once shown whispers of seasonal methane, fading and reappearing with the planet's year. Titan had thick haze, seas of methane and ethane, and complex hydrocarbons, chemistry tantalizingly close to biology, yet frozen under a distant sun. Venus, for a fleeting moment, had seemed to host phosphine, a molecule that on Earth arises from life. But closer scrutiny unraveled the claim, dissolving hope into noise. This time, the message was different. Not a lone molecule, but an ensemble. Not a singular anomaly, but a system-wide pattern. It was as though the planet had written its story in the starlight, a narrative not of sterile stone, but of restless renewal. Still, caution held its place. Nature is inventive, and the universe has surprises hidden in its laws. Some argued that exotic chemistry, unfamiliar to Earth's palate, might mimic life's signature. Volcanic outgassing, photolysis under a particular star, or yet unknown planetary dynamics could, in theory, reproduce a false harmony. The burden of proof was immense, for to claim life beyond Earth was to rewrite humanity's place in the cosmos. Yet for others, the numbers told a story too elegant to ignore. The presence of oxygen alongside methane was more than chance. It was a conversation across light years, spoken in the grammar of molecules. The Webb data came in silent streams, raw and impartial, but to the scientists who read them, they felt like scripture. Each peak and dip on a spectral graph was not mere data, but revelation, as if the universe itself were inscribing words into the margin of existence. They bent over the lines with reverence, decoding an alien tongue. The atmosphere was no longer empty, it was a voice. And in that voice, humanity heard the echo of itself. Fragile, balanced, improbable, alive. For centuries, philosophers had speculated about other worlds, imagining oceans under foreign suns, forests where strange creatures roamed, skies lit by unfamiliar constellations. Now those visions seemed less like dreams and more like translations of a real language, a cosmic text long waiting to be read. This was the shock of chemistry, not as abstraction, but as testimony. Every molecule was a syllable, every absorption line was a letter. The whole sky of that planet was a sentence, and what it seemed to say was simple, yet world-shattering. You are not alone. The scientists did not declare this conclusion. They spoke in careful tones, layered with caveats and probabilities. They used words like indicative, consistent, suggestive. But beneath the restraint lay something more primal. The recognition that in the dance of gases around a distant world, the universe had whispered a possibility as ancient as wonder itself. The planet remained a point of light, its surface unseen, but through its air it had spoken. And the James Webb Space Telescope, golden and unblinking, had written down every word. The planet was still no more than a shadow in the telescope's gaze, yet slowly, detail began to gather from the darkness. Piece by piece, its nature was drawn not from images but from patterns in light, numbers etched into spectra, models woven from physics and chemistry. It remained unseen, and yet it was becoming known. Its star was a quiet one, an orange dwarf cooler than the sun, burning steadily with the glow of spectral Class K. Smaller and longer lived, such stars could shine for tens of billions of years, granting their planets epochs of stability. Around this ember of light, the world traced an orbit within the habitable zone. Not too near, where seas would boil, not too far, where oceans would freeze. Its year was measured not in centuries but in days, for small stars keep their companions close. Yet even in that closeness, the balance seemed right for water to remain liquid, for clouds to form, for skies to breathe. The size of the planet emerged from the gentle dip of starlight as it passed across the stellar face. Larger than Earth, smaller than Neptune, it belonged to that uncertain class called super-Earths. Its mass, calculated from gravitational tugs, suggested rock and water rather than gas. Its density hinted at continents rising from oceans, at crust and mantle beneath. From faint shifts in spectrum, scientists modeled its atmosphere, then its climate. The surface temperature, constrained by stellar flux and greenhouse balance, hovered in the range where liquid water was not only possible, but likely. On its day side, sunlight would paint skies amber and gold. On its night side, under perpetual starlight, the air might glow with auroras born from magnetic fields, shimmering curtains of charged particles drawn by a planetary shield. Computer models filled the rest. They conjured oceans stretching beneath alien clouds, vast basins stirred by tides stronger than Earth's, pulled by the closeness of the star. They imagined winds sweeping across continents no eye had ever seen, sculpting dunes, forests, or barren plateaus. They sketched mountains that pierced the sky in silence, peaks carved by weathering and time, untouched by any gaze. In some models, vegetation analogues covered the land, not green, but perhaps crimson or black, tuned to the spectrum of the orange dwarf. Photosynthesis, if it had evolved, might choose different pigments, harvesting light from wavelengths Earth plants ignore. An alien forest could shimmer in hues unknown, absorbing flame-colored sunlight, releasing oxygen as quiet testimony of life. Other models reached for the sea. In the depths, bioluminescence might reign, as it does in Earth's oceans. Entire ecosystems could glow beneath storms, waves igniting with soft fire as creatures signaled in light. The night side of the planet, though hidden from its star, could gleam faintly with these living lanterns, galaxies of life mirrored in the deep. The speculations were poetic, but they rested on solid ground. Each was tethered to data, pressure ranges from transit spectra, gas abundances from absorption lines, temperatures from equilibrium models. The planet's possible faces multiplied in probability clouds, each version drawn from physics, chemistry, and the lessons of Earth. The process was as much art as science. Simulations built not only climate, but imagination. Supercomputers stitched equations into landscapes, oceans, and skies. To study such a world was to walk the line between certainty and dream, to let photons from a distant star sketch the rough edges of a map, while human wonder filled in the colors. The Webb data gave no pictures, no photographs of continents or seas. Yet when models converged, when multiple simulations pointed to oceans breathing beneath alien clouds, it felt as though the veil had lifted. The unseen world, still only a point of light, had acquired depth. It had a sky, a surface, a climate. It was no longer abstract. It was a place. The place had no name beyond a catalogue number, a string of letters and digits assigned by astronomers. Yet it invited myth, the kind of myth that once wrapped Earth's own oceans in dragons and storms before they were crossed. It was a world untouched, a page unwritten, awaiting the first chapter of contact. In every model, one truth returned. This was a stable world orbiting a stable star, cradled in a zone where conditions seemed kind to life. The thought itself was staggering. For centuries, humanity had looked upward and wondered whether such a planet even existed. Now it had one before it, not in imagination, but in measurement. The atmosphere, with its chorus of gases, had already spoken of disequilibrium, of renewal, of possible breath. Now the models built upon that, painting an alien landscape where such a balance might be sustained. The picture remained incomplete, blurred, uncertain. Yet it was enough to transform numbers into geography, chemistry into climate, physics into possibility. It was a revelation drawn from fragments of light, from faint absorption lines carried across 40 light-years of space. From those fragile signals, humanity had conjured oceans, continents, skies, perhaps even forests glowing in the alien dawn. This was the art of planetary science in its most profound form. To read the invisible, to sketch worlds from shadows, to hear whispers and imagine voices. And so the planet stood revealed, not fully, not yet, but enough to awaken the oldest of questions. If it has seas, do they shelter life? If it has forests, do they breathe? If it has skies, do they carry songs? In the stillness of space, a world had begun to emerge from the dark, and its revelation was not only scientific, it was spiritual. The recognition that humanity's imagination was not wasted, that the universe did not forbid such beauty, but allowed it, perhaps even encouraged it. The world remained beyond reach, a dream wrapped in spectra, but it was real. And in its reality, the cosmos had given a gift, a glimpse of another Earth, unseen yet alive with possibility. The numbers that emerged from the telescope's analysis were not only a scientific result, they were a tremor beneath the very foundations of human thought, a probability of 99.7%, a figure that did not whisper uncertainty but declared near certainty. It suggested that life, long considered a fragile spark confined to Earth, might be a universal flame. In that single moment, humanity was forced to look not only outward but inward at what such knowledge would mean. For centuries, the Copernican principle had quietly guided science. Copernicus himself had unseated Earth from the center of creation, showing it to be one planet among many. Galileo, Kepler, and Newton extended this principle. The heavens obeyed the same laws as falling apples and turning wheels. Einstein stretched it further, revealing that time and space themselves bowed to relativity. At each stage, humanity learned the same humbling lesson. It was not central, not exceptional, not chosen. The discovery of life elsewhere would be the next, and perhaps final, extension of that principle. It would declare that even life itself was not unique, not bound to one planet, not a miracle confined to a fragile world. Such a conclusion would not rest gently on the human mind. For millennia, cultures, religions, and philosophies had written stories of uniqueness. Myths painted Earth as a cradle chosen by gods, humanity as a favored creation. Entire moral systems were built on the belief that life here was singular, that meaning itself radiated from that singularity. To learn otherwise would not only shift astronomy, but theology. It would challenge the sense of cosmic privilege, stripping away the last veil of exceptionalism. The 99.7% probability was not simply a number. It was a challenge to identity. It stood at the threshold between awe and fear, thrilling in its implications yet terrifying in its consequence. If this distant world harbored life, then silence itself became the mystery. For decades, the cosmos had been searched for signals. Radio telescopes had swept the skies, listening for transmissions, whispers, or evidence of civilizations. Yet the skies remained mute. This absence of voice was enshrined in a question that haunted astrophysics: the Fermi paradox. If life is common, where is everyone? If worlds like Earth abound, why has no civilization crossed the void, no beacon flashed across the dark, no fleet of explorers arrived at our door? The Webb results gave the paradox a sharper edge. If one planet, examined almost at random, already yielded a near certainty of life, then the galaxy should be teeming with voices. The Milky Way contains hundreds of billions of stars, many with habitable planets. If even a fraction nurtured life, then civilization should be abundant. The silence was no longer a neutral absence. It was a contradiction, a wound in logic. Some scientists responded with restraint. They warned that biosignatures could mislead, that chemistry might mimic biology, that a 99.7% model might conceal hidden errors. Skepticism was not denial but caution, a reminder that extraordinary claims require extraordinary proof. Others felt the opposite, that the numbers were too strong, too striking to ignore. They spoke of a threshold crossed, of the silence of the universe breaking not with a signal, but with probability itself. Yet beneath the debates, the cultural weight pressed heavily. If life existed beyond Earth, even microbial, then human exceptionalism would dissolve. Earth would no longer be the oasis, but one oasis among countless. Life would no longer be the miracle, but one thread in a larger tapestry. The Copernican principle would have reached its ultimate conclusion. Humanity was not only not central in space, but not central in life. For some, this was liberation. It meant connection rather than isolation, kinship rather than solitude. To live in a universe alive was to live in a cosmos that shared. For others, it was a wound. The stories of singularity, of divine election, of human centrality would weaken. The universe would be stranger, colder, perhaps indifferent. The silence of the cosmos now carried two interpretations. Either life was common, as Webb's numbers suggested, but intelligence rare, or life was common, intelligence not rare, but civilizations destroyed themselves before reaching out. In one case, humanity might be alone among minds. In the other, it might be destined for self-erasure, the quiet fate of all species that reach for stars. And so the planet, orbiting its orange dwarf in quiet light, became more than an astronomical object. It became a mirror held to humanity's face. In its probability, it forced reflection. What does it mean to no longer be alone? What does it mean that the silence of the skies is not emptiness, but mystery. The 99.7% was not proof, but it was enough to shift the weight of belief, enough to push philosophy against its limits, enough to threaten the fragile structures of culture, faith, and self. The world revealed by Webb was not only alien, it was destabilizing. It was a reminder that in the vastness of space, the greatest discoveries are not about the stars themselves, but about the stories humanity tells of its place among them. And now, those stories would have to change. Discovery in science is never a single moment of revelation. It is a long unraveling, a careful weaving of evidence from threads so faint they are almost invisible. The numbers returned by Webb, the 99.7% probability that life-supporting chemistry lay beneath an alien sky, could not stand alone. They had to endure the weight of skepticism, the burden of verification, the trial of repetition, and so, once the first shock subsided, the work of re-examination began. Teams across the world turned back to the raw streams of data. Light curves, spectra, and calibration files were pored over as if they were ancient scripture. Was there any hidden flaw in the detectors? Any subtle bias in the algorithms? Could the faint dips in starlight, the delicate lines of absorption, be artifacts of noise rather than signatures of life? Ground-based telescopes joined the effort, though they were less powerful. On mountain summits in Chile, Hawaii, and the Canary Islands, massive mirrors opened their eyes to the same star. Instruments like the Very Large Telescope and Keck Observatory attempted to tease out confirming signals from beneath Earth's atmosphere, correcting for the turbulent distortions of air. Their spectrographs, though limited compared to Webb's, could still hint at gases, water vapor, methane, carbon dioxide. If the alignments were perfect and the star steady, even older eyes were turned back upon the data of the past. The Hubble Space Telescope, once the most powerful window into the heavens, had gathered spectra of exoplanets for decades. Its vision was not as sharp, not tuned to the infrared subtleties Webb now commanded, but its archives were vast. Scientists began to wonder, had the first whispers been there all along, overlooked, hidden in noise, waiting for a more sensitive ear to hear them? Reanalysis revealed faint traces, a blurred suggestion of water vapor in earlier observations. Anomalies once dismissed as calibration errors now seemed less dismissible. Hints of imbalance in atmospheric chemistry, unremarkable when taken alone, gained weight in retrospect. It was as though Webb had not discovered entirely new signals, but rather illuminated old ones, giving them context, giving them voice, yet the scientific community did not move as one. Debate broke across conferences and journals, splitting into camps. Some declared that the evidence was overwhelming, that the statistical weight combined with atmospheric disequilibrium made the case nearly undeniable. Others resisted, pointing out how many times in history apparent biosignatures had turned to dust. Mars had once carried canals, illusions that melted under better telescopes. Venus had once teased phosphine, a signal debated, reanalyzed, doubted into uncertainty. Even Titan, with its methane lakes, carried chemistry that was exotic but lifeless. At every turn, the cosmos had proven trickster, imitating biology with the language of geology or chemistry. Could this be another mirage? The heart of the debate lay in the difficulty of the method itself. Transit spectroscopy is delicate, almost beyond comprehension. A planet passes across the face of its star, dimming the light by a fraction. Only a tiny fraction of that light filters through the atmosphere, leaving spectral fingerprints scattered like dust across the beam. To call those faint variations evidence of life required extraordinary care. Every molecule detected had to be separated from noise, from instrument error, from the interstellar medium itself. And then came the deeper challenge: disequilibrium. Oxygen and methane together are powerful signs because they destroy each other quickly. To find both at once suggests constant replenishment. Yet could volcanoes, exotic chemistry, or unseen geological cycles mimic that balance without biology? On Earth, microbes sustain it, but elsewhere, unknown geochemical engines could exist, rewriting the script of probability. The skeptics press these questions sharply. Science thrives not on agreement, but on challenge, on the testing of every assumption. Yet beneath the arguments lay something subtler, a division of temperament. Some were cautious, guarding against error, wary of declaring discovery too soon. Others were willing to lean toward wonder, to embrace probability not as proof, but as overwhelming suggestion. Data was exchanged, reprocessed, modeled in independent labs. New statistical techniques were applied. Bayesian frameworks recalculated likelihoods. Atmospheric retrieval models tested alternative scenarios. Could clouds obscure the signals? Could stellar activity mimic absorption lines? Slowly, the models converged again and again toward the same conclusion. Equilibrium was broken. Something was breathing in that sky. But breathing what? And breathing how? The deeper the community looked, the more the mystery expanded. For in the end, light was all they had. No spacecraft had yet crossed the interstellar gulf. No probe had touched alien soil or tasted alien air. The verdict of life or not life rested on the interpretation of photons that had traveled 40 light years, stretched, scattered, and finally captured by mirrors of gold. It was humbling. To declare life from light alone was to walk the edge of certainty, balancing between triumph and illusion. Each side of the debate knew this, even as they clashed, yet the debates themselves marked progress. For centuries, the idea of alien life had belonged to philosophers, poets, and dreamers. Now it belonged to data scientists, astronomers, and statisticians. What was once speculation had become analysis. What was once dream had become evidence. The conversation had shifted from "could life exist?" to "is this life?" And that shift itself was revolutionary. The process would not end quickly. It would take years of follow-up, of new observations from both Webb and future instruments. The European Extremely Large Telescope, the upcoming Habitable Worlds Observatory, and perhaps one day interstellar probes would all contribute. But the first step had already been taken, and it could not be undone. The planet was no longer only a world in imagination. It was now a battleground of interpretation, a crucible where science tested its own ability to see the invisible. And in that crucible, one truth remained. Proving life from light alone may be the hardest test science has ever faced. Yet in facing it, humanity had crossed into new territory, where the cosmos itself began to answer the question it had always asked. For whether the skeptics or the believers were right, one fact endured. The universe had given humanity a signal worth debating, a whisper worth hearing, a possibility worth chasing. The work would continue, deeper into the data, deeper into the light, deeper into the question of whether across that gulf, beneath that alien sun, something was alive. The James Webb Space Telescope had already spoken in whispers of possibility. Its instruments had mapped the fragile breath of an alien sky. They had traced the outlines of oxygen and methane, of carbon dioxide and vapor. They had painted a world balanced in disequilibrium, a chemistry that on Earth never lingers without life. But then the telescope looked again, and in that deeper look, the whispers grew stranger, for nestled between the familiar spectral signatures was something unexpected. A set of faint, repeating lines that did not belong to the known catalogue of planetary atmospheres. Lines that shimmered in patterns uncannily reminiscent of pigments, of molecules shaped to harvest light on Earth. The same kind of lines belong to chlorophyll, the green pigment that turns sunlight into food, that anchors forests and oceans, that weaves the biosphere itself. To see something like it across light years was to step onto the edge of revelation. Yet science is cautious, bound by its own discipline. A telescope does not hand over certainty, it hands over puzzles. These spectral marks could be the fingerprints of alien photosynthesis, or they could be the echo of something entirely geologic, a mineral haze reflecting starlight in unfamiliar ways. In that ambiguity lay both the wonder and the terror of discovery. The search for biosignatures has always walked this knife's edge. A biosignature is not proof of life. It is a clue, a leaning, a suggestion. It is light bent through atmosphere, scattered, absorbed, released, until it forms a code that must be deciphered. Methane and oxygen, together water and carbon dioxide, balanced in ways unstable without biology. And now, perhaps pigments that absorb particular colors of starlight. The signals Webb caught were subtle, not the strong, bold fingerprints of gases, but delicate deviations, tiny troughs in the spectrum. So slight they could be lost in noise, yet they repeated across observations, like a faint refrain in the background of a symphony. If they were real, if they were not a statistical illusion, they would force a question as old as philosophy. Is the universe singing with life, or are we simply hearing echoes in the static? Scientists split along the old fault lines. The cautious voices spoke first. They warned that spectral analysis is vulnerable to artifacts, that unknown chemical reactions, high-energy stellar radiation, or surface minerals could sculpt signatures as deceptive as they are exotic. They remembered the phosphine of Venus, once hailed as a potential biosignature. Later tangled in doubt and reanalysis, others, however, stared at the data and felt the gravity of something more. The patterns resembled what biology does best: selectivity on Earth. Chlorophyll absorbs in the red and blue, leaving green as the color of forests. To see alien selectivity, different but purposeful, would be to glimpse adaptation written in light. It was not proof, not even close, but it was enough to demand attention, enough to escalate. The search from atmospheric chemistry to planetary character, a crossroads of interpretation where every choice reshaped humanity's understanding of its place in the cosmos. Behind the science was a deeper weight the human mind is not built for. Uncertainty stretched across galaxies. It craves resolution, a verdict, a yes or no. But the cosmos speaks in riddles. It reveals itself in hints, in probabilities, in signals that refuse to settle into clarity. The Webb data became such a riddle. Every reanalysis returned the same tension, too structured to dismiss, too ambiguous to declare it was the second shoe hanging in the air, refusing to fall. And yet, if the marks were pigments, the implications stretch beyond science. It would mean the planet was not merely habitable, but inhabited. That across oceans unseen, molecules had organized themselves to drink the light of their star. That forests, or microbial mats, or alien analogues had painted the surface with colors tuned to survival. The imagination wandered further. What if such life had evolved not in green, but in crimson, or violet, or shimmering metallic hues? What if alien continents glowed not with forests, but with bioluminescent plains, flickering beneath storms, a world breathing, adapting, thriving under skies we could only model in equations, but just as imagination leapt, skepticism anchored it back. Spectral lines alone cannot tell stories of forests or oceans. They are shadows on graphs, numerical dips, probabilities stacked upon probabilities. Light is both generous and cruel. It carries whispers across the void, but it strips them of context. It gives hints without photographs, riddles without answers. To prove life from light alone is almost impossible. The scientific community knew this, and so debate deepened. Some called for more Webb time, more instruments, longer stares into the alien sky. Others turned to Earth's telescopes, from Chile's deserts to Hawaii's peaks, to verify what Webb had glimpsed, and still others urged restraint, to not declare life before the evidence was overwhelming. This moment in science was not just technical, but philosophical. It pressed against the Copernican principle, the notion that Earth is not central, not special. If pigments truly marked that alien atmosphere, then Earth's green was not unique photosynthesis, or something like it, had emerged twice in the universe. Once here, once there, and if twice, then perhaps countless times, spread through galaxies like seeds scattered in endless fields. But if it was geology masquerading as biology, then it was a reminder of humility, that the cosmos can play tricks, and that human hunger for meaning can see patterns where none exist. The escalation was undeniable. The data had shifted the tone of inquiry. It was no longer about whether the planet could host life. It was about whether its spectrum hinted at life already unfolding, and in that escalation lay a crossroads. One path led to extraordinary confirmation, the first true detection of alien biology. The other led to disappointment, to another entry in the long history of false dawns. Either way, the world had changed, because humanity had reached the threshold where such questions were no longer idle speculation. They were tests, measurable, tangible, written in starlight in the end. The telescope itself offered no verdict. It had opened a door, nothing more. Behind that door stretched two vast landscapes, one of life, one of illusion, and humanity stood in the threshold, listening to the faintest echoes of an alien sky. The cosmos had not given an answer, it had given a riddle. And for now, the riddle was enough. The planet turned in silence, its starlight scattered and siphoned through the prisms of distant instruments. What reached Earth were not images of oceans or forests, but graphs and lines, dips and rises in spectra. Yet from these faint signatures, entire worlds of possibility unfolded. The data did not command belief, it invited theory. And in the laboratories and observatories of Earth, theories multiplied. The most intoxicating of them began with the simplest assumption that the signals were exactly what they seemed to be. That disequilibrium in gases, coupled with pigment-like absorption, was the language of life. If so, the planet might cradle microbial oceans, seas dense with single-celled organisms exhaling oxygen and methane as invisible breath. On Earth, such microbes had ruled long before forests, long before animals, long before humans. In their metabolism lay the chemistry of survival, and their traces still linger in the atmosphere of the present. To imagine another ocean, under alien clouds, whispering the same chemical song, was to imagine a cosmic mirror, a second Genesis playing out in parallel. Some went further still. They envisioned surfaces draped in photosynthetic life, not merely microbes, but vast fields of organisms harnessing their star. The spectrum suggested absorption tuned differently than Earth's green. Perhaps crimson plains stretched where alien pigments had chosen another slice of the stellar rainbow. Perhaps continents pulsed in violet or gold, their hues invisible to human eyes but written into light. The life hypothesis, seductive and poetic, fit the data too well to ignore. But science resists seduction. To see life in spectra is to walk close to mirage. And so the second theory held firm. Geology, not biology. Volcanic cycles, some argued, could mimic the breath of living things. On Earth, eruptions belch methane and carbon dioxide into skies. In violent pulses, they alter atmospheres in ways unstable yet recurrent. Could this planet's disequilibrium be nothing more than the echo of deep magma tides, gases rising from fissures, balanced precariously in air? If so, the pigment's Webb had glimpsed might be minerals, crystalline dust reflecting starlight in unfamiliar hues. The geological hypothesis offered safety, grounding the extraordinary in the known. It reminded astronomers of past lessons, of methane lakes on Titan, once mistaken for life's chemistry, but revealed as chemistry alone, of phosphine on Venus, declared a biosignature before doubt swept it into ambiguity. Geology had always been capable of masquerade, and caution demanded it not be forgotten. Yet a third path stretched wider still, the realm of exotic chemistry. Life, after all, is not bound to carbon and oxygen alone. Earth's template may be parochial, a single example among many. What if the signals did not belong to geology, and not to familiar biology either, but to something else entirely? Forms of life unrecognizable to human definitions, woven from chemistries that thrive in conditions alien to terrestrial imagination. Silicon frameworks, ammonia oceans, metabolisms that feed on energies no Earth organism has ever tasted. Such possibilities haunt astrobiology. They widen the definition of life until it blurs into mystery. This raised a question more philosophical than scientific. If a planet hosted a chemistry utterly unlike our own, a system of self-organization and reproduction, but one without DNA, without proteins, without cells, would we still call it life? Or would it become something else, demanding a new vocabulary? For centuries, humanity defined life by itself, by breathing and heartbeat, by replication and adaptation. But the cosmos does not yield to human categories. It may have written other rules in other skies. Philosophers of science lingered on this threshold. The debate was no longer only about biology. It was about language, about the human need to name. If alien processes fulfilled the functions of life, but looked nothing like its earthly template, to call them alive would stretch the word across a chasm. To deny them that name would be to risk blindness to the very diversity the universe offers. And always, beneath these theories, pulsed the tension between probability and certainty. The Webb data whispered in numbers. 99.7% likelihood that conditions match those of biology. To the human ear, such numbers ring like near certainty. But in science, numbers alone do not crown discovery. Certainty requires replication, independent confirmation, multiple lines of converging evidence. The probability was a song of seduction, but the discipline of science demanded restraint. Yet restraint could not silence imagination. If the life hypothesis were true, then the Copernican principle deepened. Earth was not singular. Biology had risen twice, in two places separated by light years. And if twice, then perhaps countless times. Oceans and forests and alien chemistries scattered across galaxies, awaiting discovery. If the geological hypothesis proved right, then the story was no less profound, for it revealed the complexity of worlds, planets capable of deceiving instruments, of weaving atmospheres so intricate they blur into mimicry of life. It would remind humanity that the universe holds trickery alongside truth, and that patience must temper awe. If exotic chemistry reigned, the consequence would be stranger still. It would demand that humanity expand its definition of itself, that it look upon alien organization not as anomaly but as kinship, different and yet parallel in the vast theater of existence. Each hypothesis carried its own gravity. Each reshaped the imagination of the cosmos, but the data would not choose among them. It offered riddles, not verdicts. It forced humanity to live in the liminal space between maybe and almost surely, between imagination and confirmation. In that space, science thrived. Models were built, simulations run, scenarios tested against spectral curves. Telescopes peered again, hoping to sharpen faint lines into clarity. Yet still, the planet remained distant, unresolved, a canvas of theories. Theories that could explain, but none that could yet prove. The signals had been received, their mystery carried across the abyss by fragile photons. But a single instrument, no matter how precise, could not bear the full burden of such a revelation. The James Webb Space Telescope had opened the first door, but beyond it stretched a labyrinth of questions. Humanity, restless and unyielding, began to forge new tools, each designed to carve deeper into the darkness, to pull secrets from the faintest starlight. The Webb telescope continued its vigil. Its golden mirrors, cooled and sharpened, turned again and again to the alien world. Repeated scans were made, each transit of the planet across its star recorded with patient devotion. The process was slow, for orbits were long and windows of observation scarce. Yet data accumulated like drops filling a chalice. Every dip in starlight, every spectral absorption line, layered upon the last, weaving a tapestry of evidence that could not be dismissed. What once appeared as a fleeting whisper began to take form, faint yet steady, like a melody remembered in fragments. But Webb, for all its grandeur, was not built to finish the story. It was a sentinel of beginnings, its instruments tuned to glimpse the edges of possibility. The future, already stirring in blueprints and laboratories, promised sharper eyes, greater mirrors, and imaginations daring to attempt what once seemed unreachable. On the deserts of Chile, the skeleton of the extremely large telescope began to rise. Its mirror, spanning 39 meters, would dwarf all that came before. Where Webb gathered light above the atmosphere, ELT would harness Earth's surface with adaptive optics, bending turbulence into clarity. It would be capable of resolving exoplanet atmospheres with a precision Webb could only hint at. With its gaze, a planet like the one whispered into existence might no longer remain an abstraction. Oceans could be inferred more clearly, clouds modeled in finer detail. It was not yet in operation, but its promise hung like a beacon on the near horizon. Even greater visions stirred in the minds of space agencies. LUVOIR, the large ultraviolet optical infrared surveyor, existed now only as design, but its ambition was vast. Its mirror, larger even than Webb's, would unfurl in orbit to cast an unblinking eye upon thousands of worlds. Unlike Webb, which relied on indirect transit spectroscopy, LUVOIR was envisioned to directly image Earth-like planets around distant stars. Its coronagraph would blot out the blinding light of the parent sun, revealing the faint glow of planetary surfaces. To see continents, oceans, even the glimmer of cloud belts with one's own instruments, this was the dream it carried. Beside it on the drawing boards was HabEx, the Habitable Exoplanet Observatory. Smaller than LUVOIR but equally bold, it carried with it a concept of staggering elegance, the starshade. A vast, flower-shaped screen would fly thousands of kilometers away from the telescope, perfectly aligned to block starlight. In the sudden artificial eclipse, a planet could emerge in direct view, its light unmasked, its spectrum unbroken by stellar glare. To witness an Earth twin in this way, bathed in its own light, painted not in probability, but in direct vision, would be to move from speculation into revelation. These missions were not fantasies. They were being studied, budgeted, debated. They carried timelines measured in decades, but history had shown that the arc of exploration bends forward. driven by a hunger that no obstacle can fully starve. In the meantime, other instruments lent their strength. Ground-based telescopes like the Keck Observatory reanalyzed old starlight, searching for subtle variations that Webb's discoveries had now made meaningful. The Hubble Space Telescope, though aging, was revisited, its archival data combed for overlooked patterns. The past, it seemed, had been storing secrets, waiting for the present to awaken them. The frontier of spectroscopy also advanced. New methods allowed astronomers to separate planetary signals from stellar noise with ever greater precision. Algorithms born of machine learning began to recognize patterns too faint for human eyes, teasing order from the chaos of photon scatter. What once demanded decades of manual comparison now unfolded in weeks of computation. The data, once cryptic, began to sing in chords instead of notes. And still, at the heart of it, lay the same question. Was the planet alive? The tools were being forged not merely to study atmospheres, but to approach this singular abyss of knowing. The challenge was staggering. Life is not a molecule, nor a pigment, nor a gas imbalance. It is a system, an emergence, a persistence across time. To prove its existence at light years remove required technology that could, in essence, watch a world breathe. That was the dream of direct imaging. To capture reflected starlight from an alien ocean, to measure its shimmer as clouds drifted and storms broke, to watch a planet turn and glean from the rhythm of light the presence of continents. Already, models predicted the patterns. The way ocean blue and cloud white would alternate across a globe. The way forests, if forests there were, might alter reflectance as seasons shifted. Each simulation was a promise of what could be seen once tools caught up to imagination. Yet even more daring ideas emerged. Interferometers in space, linking multiple telescopes across vast separations, could one day achieve resolutions sharp enough to see exoplanets in detail, unimaginable now. The dream stretched further. One day, the first map of an alien world's surface, pixel by pixel, might be drawn. A world once invisible might be revealed as an orb of oceans and land, its storms swirling in time-lapse across a canvas of alien days. Humanity stood, trembling, at this threshold. Behind it lay centuries of speculation, from philosophers who wondered whether Earth was alone, to astronomers who first glimpsed planets orbiting other stars. Before it lay a future where isolation might finally be broken, not by signals sent but by light received. In the silence of space, tools were being forged. Not weapons, not monuments, but instruments of seeing. Golden mirrors and star shades, algorithms and arrays, each one a key fashioned for a lock not yet turned. The questions were old. Are we alone? Is life a singular spark or a universal fire? The answers waited in starlight, and for the first time humanity's hands held the beginnings of tools strong enough to draw them out. The Webb telescope had whispered the first possibility. The instruments of tomorrow promised to speak in sentences, and beyond them, a day would come when the universe itself might be read like a book, its pages filled with the stories of other worlds, other lives, other dawns. Humanity stood not at the end of wonder, but at its beginning. The story of Earth begins not with continents or creatures, but with silence and shadow. For hundreds of millions of years after its birth, our world was wrapped in oceans of stone and seas of fire, its skies veiled in toxic haze. Life, as far as the rocks can tell, was already present, small, fragile, and invisible. Microbes clung to cracks in volcanic rock, fed on chemical gradients, and multiplied in the darkness of hydrothermal vents. They left no skeletons, no footprints. Only faint isotopic whispers in ancient minerals mark their existence. This was Earth at 3.5 billion years old, a planet alive, but in ways almost imperceptible. And it is here, in these cryptic beginnings, that comparisons emerge with the strange world whose atmosphere now troubles our instruments. Could the odd signatures we detect be nothing more than an echo of our own first breaths? A planet still waiting to awaken fully, its future creatures still imprisoned in the deep simplicity of microbial dominion. The great oxidation event on Earth some 2.4 billion years ago was not a sudden blaze but a slow, grinding revolution. Cyanobacteria, tiny architects of planetary change, began to release oxygen into the oceans and sky. For millions of years, that oxygen was swallowed by iron in the seas, staining the world in rust-red stone. Only when the oceans were saturated did oxygen finally escape into the air, changing chemistry, climate, and the fate of every organism to come. What followed was still slow. Over 1 billion years of microbial reign, while multicellular forms slumbered in possibility. When astronomers look at an exoplanet's spectrum and see traces of oxygen, methane, or other disequilibrium gases, they are peering across billions of years of possible evolutionary timelines. The question is not simply whether there is life, but at what chapter that life exists. Is it still crawling through its infancy, locked in microbial patience? Or has it already advanced beyond recognition, far ahead of us, reshaping its own biosphere with tools beyond our comprehension? Probability whispers that most worlds may dwell in the microbial stage. On Earth, for nearly 90% of its history, bacteria and archaea were the only citizens. Complex life is not inevitable. It is the outcome of chance converging with catastrophe and stability. A rare balance of planetary chemistry, tectonic cycles, and cosmic accidents cleared the path for animals and plants. Without mass extinctions, without snowball Earth episodes, without the long patience of microbial photosynthesis, the page of Earth's story might still be dominated by mats of algae clinging to tidal flats. Yet speculation lingers. If Earth is not unique in these events, if planetary histories unfold with rhythm across the galaxy, then there may be worlds where the great oxidation came early, where multicellular complexity had time not for hundreds of millions of years, but billions. On such planets, life could be older than the oldest forests of Earth, older than the very notion of mammals or humans. What would such maturity look like? Forests of silicon-like biochemistry? Oceans thrumming with minds we cannot categorize? Or perhaps civilizations so ancient that their markers are geological, their artifacts buried in planetary crusts, indistinguishable from natural stone? Here lies the philosophical fracture at the heart of astrobiology, the distinction between probability and identity. Science may tell us that life is likely elsewhere, because the chemistry that made us is not rare, because carbon, hydrogen, nitrogen, and oxygen are scattered like seeds through every nebula. But science cannot tell us what kind of life will emerge, nor how it will appear in the brief flicker of our observation. A planet's spectrum may only reveal imbalance, a whisper that something stirs, but not whether it is a single-celled ocean or a civilization that gazes at its own stars. When viewed against this uncertainty, Earth itself becomes both guide and limitation. It is our only data point, the one living example against which every alien signature is measured. This is both powerful and perilous. Powerful because it provides a narrative of how chemistry can become biology, and biology can sculpt a planet. Perilous because it tempts us to assume that other worlds must follow the same path. Yet nature rarely repeats itself in identical forms. Just as no two forests are alike, no two planets may tell the same story of life. The echoes of Earth's past may be just that. Echoes. A world in its oxygen dawn could remind us of our own Archean age, but its future may diverge entirely. Perhaps its microbes never give way to animals. Perhaps they evolve in forms that do not rely on oxygen at all, building complexity from molecules alien to our biochemistry. The very word life may become stretched, strained against categories born only of Earth's example. And then comes the other possibility. Not infancy, but age. That the planet whose light we study is not a mirror of Earth's youth, but a window into Earth's possible future. What does life look like after 5 billion years of experimentation? After oceans rise and fall? After continents drift and shatter? After evolution has turned every stone twice and found new ways to weave the fabric of survival? Such a world might hold forests made of living crystals, or seas where bioluminescence is not decoration, but the foundation of food chains. It might hold organisms that spread across continents not as species, but as networks, connected like neurons across the surface of a planet mind. The tension between these visions, a world just beginning, or a world unimaginably advanced, cannot be resolved by probability. It is the tension of science itself, between knowing what is likely and confronting what is real. Instruments can detect molecules, ratios, imbalances. They can measure photons scattered by alien skies, but they cannot yet tell us whether what stirs there is simple or profound. On Earth, the silence of the Precambrian is broken only by stromatolites, layered microbial tombstones rising from shallow seas. They remind us that most of life's story is invisible to the naked eye. If our planet had been observed from light years away during that long epoch, its spectrum would have shown oxygen, methane, and water vapor. signs that something was alive. But it would have told nothing of the waiting forests, the hidden trilobites, or the apes who would one day build telescopes. And so, when astronomers speak of alien life, they speak in whispers of Earth's own memory. They see in the spectra of distant planets not only gases, but ghostly parallels. The breath of microbes, the rusting of seas, the chemistry of waiting. They wonder if another world now rests in its own billion-year silence. Its story paused between the first spark of metabolism and the eventual thunder of complexity. Yet always lingers the other whisper. What if it is ahead of us? What if its echoes are not of our past, but of our future? What if, while we search for microbial dawns, we are overlooking civilizations at dusk, lives older than mountains, fading into transformations beyond our comprehension? In this uncertainty lies both humility and wonder. Earth is not the model for life everywhere. It is simply the one story we know. Every spectrum captured by telescope, every photon dissected, may be a chance to compare our fragile thread to a vast tapestry still unseen. Whether young or old, microbial or magnificent, each discovery will speak not only of alien worlds, but of our own origins, our own fragility, our own improbable survival. The echoes of Earth's past stretch outward into the stars. They remind us that we are not observers apart, but participants in the same cosmic process. Whatever breathes beyond the dark, whether it resembles the microbes of our youth or the dreams of our future, it will not diminish Earth's story. It will complete it, transforming our single data point into the first note of a chorus. And in that chorus, the silence of isolation will finally break. For generations, humanity has stared at the night sky and wondered why it does not answer back. The stars are countless, the galaxies innumerable, and the chemistry of life universal. Yet in all our listening, in all the decades of radio dishes turned toward the dark, there has been only silence. This is the riddle that has haunted science and philosophy alike. Fermi's paradox. If life is common, where is everyone? But the discovery of a living planet changes the equation. The silence, so long thought absolute, fractures. If one world orbiting a star not so distant carries the chemistry of life in its skies, then probability dictates that life is not rare at all. In one detection, the paradox shifts. The question is no longer if life exists, but why the universe has hidden its voices. The silence becomes heavier, not lighter. For if life is likely, then absence of signal is not ignorance, but mystery. Somewhere between probability and evidence lies an unsettling truth. The stars should be alive with messages, yet they remain mute. Some scientists whisper that civilizations may die young, that the leap from biology to technology carries a burden too heavy to bear. Nuclear fire, climate collapse, engineered plagues, the dangers of intelligence are legion. If life arises often, but wisdom rarely endures, then the galaxy may be littered with ruins. Civilizations cut short before their voices could cross the void. Each silence we hear may be the silence of extinction, echoing across centuries of light. Others suggest that survival requires silence itself, that advanced societies may learn to hide, cloaking their signals in fear of predators. Just as animals in a forest grow quiet when danger prowls, so might civilizations in the cosmic dark. If the universe harbors hunters, species that rise to dominance by consuming others, then the great hush is not absence, but caution. We do not hear them because they dare not speak. And yet another possibility lingers, that they are speaking, but in languages beyond recognition. Humanity's ears are tuned to radio, its eyes to narrow slices of light, but the spectrum of communication may be vast. Civilizations may converse with neutrinos, with gravitational waves, with quantum entanglement stretched across interstellar space. To us, the night would seem quiet, even as it is alive with conversation in tongues our technology cannot yet hear. Philosophers see in this silence a mirror of human solitude. For centuries, Earth believed itself the center of creation, until telescopes revealed a universe of galaxies. Then, Earth believed itself the only living world, until the chemistry of alien skies suggested otherwise. Each step has humbled, each discovery shrunk the island of human uniqueness. Yet still, in all the vastness, there remains no voice to greet us. The loneliness endures, sharpened now by the knowledge that life is not unique, but still unshared. It is a paradox turned inside out. Before, silence could be explained by rarity. Perhaps Earth was one among billions, its life a singular accident. But now, if even one nearby world breathes, then life is not rare. The silence must have another cause. The universe is not empty. It is quiet with intent. The weight of that realization presses against the edges of human imagination. To know that others almost certainly exist, yet remain unseen, is to stand at the edge of an abyss of meaning. Do they watch us, patient and hidden, the way naturalists observe animals in the wild? Or have they chosen a silence of indifference, their concerns turned inward, their civilizations vast and ancient, but uninterested in the fragile sparks of younger worlds? Some scientists propose the idea of the Great Filter, an unseen barrier in evolution that prevents most life from advancing to interstellar reach. It could lie behind us, in the improbable leap from molecules to metabolism, or from microbes to multicellular life. If so, then humanity is rare and precious, a survivor of impossible odds. But it could also lie ahead, in the perils of technology, in the fragility of planetary ecosystems, in challenges we have yet to face. If the filter waits before us, then the silence of the stars is a warning. Many have tried, but none endure. And yet, silence can also be profound in another way. It may be the pause before an answer, the moment when the universe holds its breath. If life is scattered everywhere, then sooner or later, voices will meet. The distances are vast, but not infinite. Light travels, civilizations rise and fall, but across billions of years, chance may eventually weave connections. The silence of today may be the prelude to a chorus tomorrow. The eerie quiet around a near-certain living world becomes both haunting and beautiful. To detect life but hear no signal is to glimpse a mirror of our own past. For most of Earth's history, it too was silent. Microbes ruled, but they sent no messages to the stars. If another civilization had scanned our skies 3 billion years ago, they would have found oxygen, methane, and seas alive with bacteria. Yet they would have heard nothing more. Perhaps the planet we now watch is in just such a stage. Its oceans filled with life, but its skies devoid of radio. If so, the silence is not absence, but patience, awaiting billions of years long. But if that world is older, if its life is advanced, then the silence is stranger still. For what could restrain such beings from speaking? Indifference, fear, a wisdom that deems communication unwise, or perhaps they speak, but not to us, conversing instead with others already known, leaving humanity as the unnoticed newcomer at the edge of a vast, ongoing dialogue. The silence breaks not with noise, but with knowledge. The paradox collapses under its own weight. Life exists elsewhere. That truth alone is enough to end the loneliness of hypothesis. Yet the absence of voices ensures the loneliness of experience remains. Humanity is not alone, but it is still unheard. In that tension lies the new frontier of wonder and dread. To look up at the stars and know that life stirs among them, and yet to hear only the quiet hiss of empty space, is to glimpse the complexity of existence itself. It is to realize that the universe is neither empty nor welcoming, but something deeper, stranger, and more subtle. The silence of the universe is no longer a void. It is a mystery, with edges sharp enough to cut. It is the quiet of hidden lives, the stillness of civilizations unseen, the echo of futures we do not yet understand. And as humanity listens harder, with new tools and new patience, the question becomes not whether the silence will break, but what voice will emerge when it does. For when the universe finally speaks, it may not whisper comfort. It may reveal beauty beyond imagination, or truths heavy with sorrow. But until that moment comes, humanity stands in a quiet charged with meaning, a silence that is no longer emptiness, but presence concealed. The silence of the universe has broken, not in sound, but in certainty. Life exists, and in that certainty lies both the promise of connection and the weight of solitude, as the stars hold their secrets a little longer. The news spread across the world not as a whisper, but as a wave. It crossed oceans and borders, filling headlines, echoing through crowded streets, flowing into homes where children stared wide-eyed at glowing screens. The words were simple, but their weight was immense. We are not alone. In every language, in every city, the announcement carried both a shiver of fear and a quiet astonishment. Some greeted it with tears, others with silence, some with prayers whispered to heavens they thought they understood. The confirmation of life beyond Earth did not arrive with thunder, nor with the landing of ships, but with the measured cadence of science. Spectra of light, models of probability, gases in disequilibrium. These were the messengers. Yet for billions, the technicalities mattered little. The truth was plain. Another world breathes. Awe settled over the collective human mind. It was not the awe of discovery alone, but of recognition. The sudden realization that the long solitude of Earth had ended. For centuries, humanity had looked upward with questions. Now, the night sky itself felt changed. Stars that once seemed distant, cold, indifferent, now shimmered with possibility. Every point of light carried a new whisper. Perhaps there too oceans roll. Perhaps there too beings wonder as we wonder. Yet alongside awe came fear. If life is near, then humanity is no longer the solitary witness of creation. The uniqueness that once anchored philosophy, religion, and identity begins to fracture. Some feared what such knowledge might awaken. If others exist, are they peaceful or hostile? Advanced or fragile? Close or impossibly far? In the absence of answers, imagination rushed to fill the silence with both dreams and terrors. Religious traditions felt the tremor. For some, the discovery confirmed belief that creation was vast, that the divine surely seeded life beyond a single world. For others, it posed unsettling questions. Sacred texts written in the age of one world now faced the reality of many. What becomes of doctrines built on human centrality when humanity is revealed to be one of countless living expressions? Priests, imams, rabbis, and monks debated in hushed halls, each seeking meaning in the newly expanded cosmos. Philosophers too turned toward the heavens with renewed urgency. Existentialists spoke of the end of human isolation, of an absurdity now transformed. If life is common, then the universe is not indifferent, but fertile. Others argued that the silence of voices still implied a darker truth, that intelligence falters, that civilizations perish before they can connect. The paradox sharpened, not softened. Life is out there, yet it does not speak. Humanity is not alone, but it is not yet accompanied. Governments reacted with caution. In secure rooms, intelligence agencies and policymakers debated the implications. A discovery of microbes was one thing, but if the signals hinted at complex life, then strategies of communication, defense, and diplomacy would inevitably follow. Budgets shifted. New missions were drafted. Telescopes not yet built were suddenly deemed urgent. The search for understanding became not only scientific, but political, woven into the strategies of nations preparing for a cosmos that was no longer silent. But outside the halls of power, in the quiet lives of ordinary people, the emotional truth was simpler. On balconies, on rooftops, in fields and deserts, people began to look upward differently. The night sky was no longer a backdrop to human life. It was a stage shared with others unseen. A child in Nairobi, a farmer in Punjab, a teacher in São Paulo, a grandmother in Kyoto, each in their own way, turned their gaze to the stars and wondered who might be staring back. The weight of this moment was not measured in data alone, but in a shift of perception. The universe, once abstract, had become personal. For the first time, humanity felt itself part of a story larger than Earth. Each breath drawn beneath the stars carried with it the knowledge that somewhere, beyond the reach of sight, another world also breathed. The cosmos had become intimate. Art reflected this transformation. Painters turned canvases into visions of alien seas. Musicians wrote symphonies to echo the vastness of new horizons. Poets filled pages with stanzas about unseen neighbors, about the long silence now cracked by light. Cinema, literature, and philosophy swelled with new narratives, each grappling with the same revelation. Humanity's story was no longer singular. The reaction was not uniform. Some communities resisted, clinging tighter to old beliefs, rejecting the intrusion of science into sacred mysteries. For them, the data was not proof but illusion, a trick of instruments. Others embraced it fully, declaring the dawn of a new era. And most, caught between wonder and uncertainty, simply looked upward with questions that no telescope could yet answer. Scientists themselves felt a mixture of triumph and humility. Years of patient labor, of equations and calibrations, of doubts and debates, had culminated in evidence strong enough to bend the arc of history. Yet they knew how fragile such evidence could be. Every spectral line, every statistical model demanded caution. The public saw certainty. The scientists still saw margins of error, alternative hypotheses, the painstaking work of verification. But they also felt awe, not only as researchers, but as humans gazing with the same wonder as everyone else. The shock of this revelation rippled across disciplines. Biologists considered the forms life might take, freed from the template of Earth. Chemists debated exotic reactions, while physicists pondered the rarity of intelligence within the sweep of cosmic law. Anthropologists speculated how culture might evolve on worlds under red suns or frozen skies. The discovery was not a single question answered, but 1,000 new questions opened. And through it all, the night sky remained unchanged. The stars still burned as they always had. Yet to those who looked up, nothing was the same. For the first time, the human species saw itself as part of a continuum, one living branch among countless others, each rooted in the soil of stars. This is the quiet emotional truth. No one could look at the heavens in the same way again. The child tracing constellations, the astronomer aligning lenses, the dreamer standing barefoot on grass at midnight. Each gaze carried new weight. The darkness above was no longer empty. It was inhabited. In that gaze lay a reorientation of humanity itself. Nations that once warred over boundaries now shared a horizon that extended beyond Earth. The discovery did not erase conflict, but it reminded the world of a larger perspective. Beneath the fragile veil of atmosphere, 8 billion hearts beat on a planet that was no longer alone. A new humility dawned. Humanity's achievements, its art, its science, its empires, its revolutions, became smaller against the vast backdrop of living cosmos. And yet, paradoxically, humanity's significance deepened. For to be alive in this moment, to be aware of the wider community of existence, was to hold a place in history as profound as the first creature that walked upright, or the first sailor who crossed an ocean. The cosmos had spoken not in words, but in chemistry. It had answered the question that had haunted generations: are we alone? And in doing so, it reshaped not only science but spirit. The discovery did not diminish humanity, it expanded it, weaving Earth into a greater tapestry of life. In the years that followed, debates would continue. Philosophers would argue, governments would plan, telescopes would peer deeper. But in the hearts of countless individuals, the meaning was simpler. Each time the night spread its stars overhead, each time the moon rose above the horizon, there would be a pause, a moment of quiet reflection. And in that pause, a question shared across cultures and languages: who else is out there? For in the end, the discovery was not about alien worlds alone. It was about Earth and the way its inhabitants saw themselves. To know that life exists beyond is to know that humanity is not the only witness of the universe, but part of a chorus not yet heard. And in that knowledge, every upward glance becomes both an act of wonder and of kinship. The night sky, once a canvas of mystery, had become a mirror. In its stars, humanity now saw not only questions, but echoes of itself, fragile, enduring, searching. And though the silence remained, the gaze had changed forever. Humanity looks up, and the stars, silent as ever, shine with new meaning. The discovery of another inhabited world would not end the story. It would begin a new one, equally vast and equally humbling. Because to see is not the same as to touch. To know is not the same as to reach. The distances involved are merciless. Even the nearest stars, those faint glimmers beside the sun, lie trillions of kilometers away. Proxima Centauri, the closest, sits at just over 4 light-years, a distance so immense that a beam of light, traveling at the fastest speed allowed by physics, takes more than 1,400 days to bridge the gulf. Every craft ever built by human hands, from Voyager's aging probes to the speediest flybys of Jupiter and beyond, moves 1,000 times too slowly to make such a journey in any human lifetime. At their pace, a crossing to the nearest star would require tens of thousands of years. Civilizations would rise and collapse before their emissaries arrived. To stand at this horizon is to feel the full weight of cosmic scale. Worlds might shimmer in the data of telescopes, oceans traced in subtle spectra, clouds mapped in reflected starlight. But they remain phantoms beyond reach, hovering like mirages across deserts that no caravan can cross. And yet, imagination refuses to rest. In quiet laboratories, physicists and engineers sketch the outlines of ships that might one day attempt the impossible. Generational vessels, habitats vast enough to carry entire lineages across the stars, cities sealed in steel, with forests in hydroponic bays, rivers coursing through recycled channels, societies unfolding under alien suns they would never themselves see. Only their descendants, hundreds of generations removed, would glimpse the destination. Such a craft is not yet possible, but the idea lingers, half dream and half plan, etched into the margins of aerospace journals. More daring still are the sails of light, sheets of reflective material, thinner than paper, propelled by the gentle pressure of photons. Lasers from Earth could drive them outward at fractions of light speed, carrying probes no larger than a hand. The Breakthrough Starshot initiative imagines such missions. Swarms of microsails racing toward Proxima Centauri, cameras on board, transmitting images of another sun and its planets within a human lifetime. If such sails succeed, they will not carry people, but they may carry the first whispers across the interstellar sea. Further on the horizon lie stranger engines, theoretical drives fueled by fusion reactions, tiny stars ignited in containment fields, their outbursts directed for thrust. Others imagine antimatter annihilation, harnessing the most efficient energy release known to physics. And beyond even these waits the speculation of warp, a distortion of space-time itself, contracting distances in front of a vessel while expanding them behind. Mathematics permits the geometry, discovered in 1994 by Miguel Alcubierre, but the energy requirements exceed comprehension. Negative mass, exotic matter, quantities far beyond any feasible scale. At present, warp is not a design. It is a metaphor, a reminder of how far the boundary lies. So the question arises, not merely technical, but philosophical. Is discovery enough? If humanity can see oceans shimmering on a far-off world, if spectra reveal oxygen, methane, and the dance of seasons, is contact truly necessary? Or is knowing that such a world exists already enough to reshape how the species understands itself? Some argue that presence is essential, that until a human hand has touched alien soil, the story is incomplete, that only in standing beneath another sky can a civilization prove it has crossed its own horizon. Others suggest that the act of seeing itself is contact, not physical but cognitive. The photons arriving in our telescopes are the world's emissaries, crossing the abyss, whispering their reality into our instruments. In that sense, the connection already exists, but the haunting truth remains. The gulf is vast enough that, for all practical purposes, the world may remain forever untouchable. An eternal vision, a silent promise, a reminder of limits that even ambition cannot erase. Astronomy has always wrestled with this paradox. The moon was once untouchable, until a century of engineering shrank the impossible to a footprint in dust. Mars too seems distant, yet rockets already test the path. But stars beyond the sun are different. They are not distant merely in miles. They are distant in kind. To cross to them requires not simply better engines, but new laws of motion, new energy regimes, new civilizations built for epochs rather than years. In this sense, the horizon of contact is not only physical, it is temporal. It demands patience longer than history has ever held. It demands a continuity of purpose across centuries, cultures, and crises, for humanity has rarely held one vision for so long. And so the idea of interstellar travel becomes less an engineering project and more a mirror. It reflects what the species values most. If curiosity endures, if the desire to touch outweighs the comfort of staying, then perhaps the first long arcs will be laid. If not, the worlds will remain eternal mysteries, lights in the sky never reached but always watched. There is, in this, a quiet beauty, because even if contact never comes, the knowledge that such places exist changes everything. It rewrites myths, it alters religions, it shifts philosophy, it teaches a civilization that it is neither central nor alone, that the story of life may be written in chapters scattered across the spiral arms of the Milky Way. Perhaps this is enough. Perhaps to know is to belong. Perhaps to see is already to touch. Across the only bridge the universe offers, the ancient flight of light itself. And yet, when a child lifts their eyes to the night sky, when telescopes reveal oceans beneath alien suns, there will always remain a longing not satisfied by spectra or maps, a longing to stand where no foot has stood, to breathe an air not of earth, to watch another dawn from another shore. This is the horizon of contact, the boundary between knowledge and presence, between vision and touch. It is a line humanity may never cross, but it is also a beacon, urging thought forward, pulling imagination outward, keeping alive the restless hope that even in a universe of impossible distances, the journey has only just begun. When a distant planet is glimpsed through the trembling light of a star, It does not arrive in the human mind as rock and orbit alone. It arrives as reflection, a mirror suspended in the void. For in the subtle traces of oxygen or methane, in the faint shimmer of oceans or the whisper of clouds, humanity does not see only the possibility of another life. It sees itself. Every spectrum becomes more than data. It becomes confession. What is sought on that world is what is longed for on this one. The hope that life is not singular. The fear that humanity is fragile, transient and solitary. The dream that existence has a larger stage. That meaning can be found in cosmic company. In searching for the other, humanity searches for its own reflection. History has always carried this pattern. When the first oceans were crossed, when continents unknown to some were encountered by others, explorers projected myths upon their maps. Monsters, paradises, the edges of Eden, all were painted on coasts unseen. The unknown was never empty. It was filled with what human imagination feared or desired most. And so too with exoplanets. Even before they are reached, they are laden with destiny. They become the screens upon which the species projects its deepest questions. Science remains cautious, precise, withholding judgment, but imagination drifts freely. A planet with oxygen becomes a cradle. One with methane suggests the possibility of metabolism, the spark of industry. One with oceans becomes a stage for leviathans, for forests unseen, for skies thick with wings. Yet all of these visions, though draped upon the stars, are reflections of Earth. They echo its mountains, its creatures, its myths. The cosmos is asked to provide another Earth, not only because another Earth might exist, but because humanity cannot help but search for itself in the mirror of the unknown. This is the paradox of discovery. The telescope is aimed outward, but the gaze bends back inward. Every world becomes a commentary on human existence. The lifeless ones, barren rocks, charred gas giants, frozen deserts, remind humanity of fragility, of the narrowness of the band where life can thrive. The possible Earth-like ones remind humanity of resilience, of the stubborn insistence of life to emerge where it can. Even silence becomes a mirror. For if the galaxy remains empty, that emptiness too reflects something essential about the human condition. That meaning must be made, not found. In this way, the search for extraterrestrial life is less about escape and more about understanding. It is not simply a hunt for neighbors. It is a meditation on solitude. Each detection of a distant atmosphere becomes a verse in an unspoken dialogue, in which the universe says nothing and humanity interprets everything. Religions feel this mirror as well. For millennia, they have oriented human identity in relation to the heavens. Creation stories framed by stars, gods aligned with constellations, destinies written in the night sky. The discovery of another living planet would not only expand astronomy, it would expand theology. Questions once confined to Earth would echo in larger halls. If life exists elsewhere, does it share the same origin? Is it subject to the same moral arc? Or does the mirror reflect diversity beyond human comprehension, suggesting that meaning itself is broader than any single story told on Earth? Philosophers, too, feel the pull of the reflection. The search for exoplanets has already shifted the axis of thought, nudging the species away from geocentrism not only in mechanics, but in meaning. Each new detection widens the horizon of possibility, forcing the question, is life rare, a singular spark in a dark cosmos? Or is it common, scattered like embers across the spiral arms, each ember a possible reflection of the same fire? The answer matters less for what it says about the stars, and more for what it says about humanity's own sense of significance. The public feels this reflection most directly. Headlines declaring another Earth found are read less as science and more as prophecy. The details, mass, radius, orbital resonance, fade into background. What remains is a vision, a blue-green marble, a twin, a mirror. The planet may be dozens of light years away, unreachable by any foreseeable ship. Yet in imagination, it is already neighbor, already myth. People picture homes, forests, children under its skies. They project stories of escape, salvation, destiny. In the distant reflection, they see answers to long-standing fears, that the species is confined, that the future is fragile, that the Earth alone may not be enough. But the mirror does not only reflect hope, it reflects dread. If another planet holds life, what if it is indifferent? What if it is hostile? What if the mirror reveals not a companion but a rival? The same fears that once haunted explorers on Earth are now cast outward, onto the stars. Every reflection carries both light and shadow. In this dance of projection, the planet itself is silent. It is what it is: atmosphere, orbit, chemistry. The mirror reflects not because it intends to, but because humanity cannot look without seeing itself. The cosmos becomes a canvas of introspection, and perhaps this has always been its role. The night sky has never only been observation. It has always been interpretation. Constellations are patterns imagined, not inherent. Astrology, navigation, poetry, all are mirrors of human need. Exoplanets are simply the next mirror. Sharper, deeper, more vast. The poetic truth lingers. In searching for life elsewhere, humanity is searching for meaning here. It is not the alien that compels, but the possibility of belonging to something larger. The idea that life is not an accident, not confined to one fragile sphere, but a principle that echoes across space and time. To find another world alive would not erase loneliness entirely, but it would soften its edges. It would suggest that existence is not a singular island, but an archipelago. And even if the search yields silence, the mirror still reflects. For in silence, humanity is forced to reckon with itself, to face the truth that meaning may not be gifted by the cosmos, but created within. That the mirror shows not only hope or fear, but responsibility. For if Earth is alone, it becomes all the more precious, all the more sacred, the only oasis in an otherwise lifeless sea. Thus the mirror of existence is twofold. It shows the possibility of others, distant and unreachable, and it shows humanity itself, fragile and searching. Both reflections are true. Both matter. Perhaps that is the ultimate purpose of the search. Not to escape, not to colonize, not even to communicate, but to understand, to see in the stars the outlines of the human spirit, cast back across the void, to realize that the longing for connection, whether fulfilled or not, is itself the most human trait of all. The mirror waits in the sky, polished by light years, framed by silence. Each time a telescope turns toward it, humanity peers not only into space, but into its own reflection. And in that reflection lies the deepest answer, that in reaching outward, the species is truly reaching inward. That the universe, vast and indifferent though it may be, has become the stage on which humanity learns to see itself more clearly. The planet is there, the mirror is here, and between them stretches the eternal dialogue of existence. The search ends not with certainty, but with reflection, a planet glimpsed in fragile detail. Its spectral whispers carried across light years has unsettled the silence of the universe. It has not spoken outright. It has not revealed oceans with unambiguous shimmer, nor cities illuminated by night. It has only given breath, faint gases where none should be, improbable patterns in the spectrum of its star. And yet those whispers weigh more than centuries of speculation. For if life is nearly certain on one world, then probability itself becomes revelation. The galaxy, with its hundreds of billions of stars, no longer stretches as a void, but as an ocean alive with unseen shores. The silence that haunted philosophers and scientists for generations, the silence of the Fermi paradox, begins to collapse. The absence of signals may not be absence at all. It may be distance, timing, fragility. It may be the simple truth that civilizations rise and fall like tides, leaving only traces too faint to catch. But life, the primal pulse of metabolism and replication, appears woven into the very fabric of possibility. To glimpse it once is to suspect it everywhere. This realization reshapes humanity's place in the cosmos. In one sense, it makes the species smaller. Earth no longer stands solitary, no longer unique. Its story may be only one among countless others scattered through the spiral arms. The great human drama, with all its wars, triumphs, philosophies, and faiths, may be but a verse in a galactic chorus. But in another sense, the discovery enlarges humanity beyond measure. For to know the universe is alive is to know that life is not fragile anomaly, but principle. And to be part of that principle is to belong to something unimaginably vast. The James Webb Space Telescope, with its golden hexagons polished to capture the faintest of photons, has become the first mirror to hold this reflection. Each photon it receives has crossed centuries, slipping past the gravities of stars, brushing the edges of dust clouds, surviving the emptiness of interstellar night. And in their final instant, they are caught by mirrors built by human hands, turned into spectra, decoded into meaning. Light that left its home before modern science was born now tells a story of another world, perhaps even of another breath. The weight of such knowledge is both scientific and philosophical. It demands proof, replication, restraint, and yet it awakens awe, reverence, and a tremor of humility. For if another world carries life, then existence itself is less about rarity and more about inevitability. Life is not miracle, but pattern. Not exception, but expectation. Still, questions linger in the silence. Why, if the galaxy is alive, does no voice reach Earth? Perhaps civilizations burn bright but brief, consumed by their own instability. Perhaps communication requires spans of time so vast that overlaps are rare, a cosmic lottery in which alignment seldom occurs. Or perhaps the voices are there, layered in forms unrecognized, subtle as wind on grass, waiting for perception to widen. The silence is not emptiness, it is mystery, a canvas still awaiting interpretation. Yet even if no signal ever arrives, even if the distance between minds proves insurmountable, the meaning remains profound, for the cosmos itself is revealed as fertile. And in that fertility, humanity finds connection, not through dialogue, but through kinship. Every molecule of oxygen, every trace of methane on a distant world, becomes a reminder that the processes shaping Earth are not isolated. They belong to a cosmic grammar written across billions of planets. Life, in whatever form it takes, may be the most natural outcome of matter under light. In that thought lies a quiet transformation. Humanity, so often fractured by borders, cultures, and histories, glimpses its shared reflection in the stars. The discovery does not dissolve difference, but it places it in scale. All divisions shrink when set against the immensity of a universe alive with possibility. The night sky becomes not backdrop, but community. Each star, a potential neighbor. Each planet, a potential story. This is the breath between stars, the recognition that the universe inhales and exhales life in rhythms too vast to measure. That Earth's forests, oceans, and cities are not isolated miracles, but participants in a wider cadence. That the silence humanity once feared was perhaps never silence at all, but waiting. Waiting for instruments to grow sensitive enough, for minds to grow open enough, for perception to finally align with reality. The journey does not end here. It begins here. The next telescopes will sharpen the image, capture oceans glinting in starlight, map continents by the faint shading of reflected glow. Spectroscopy will refine until pigments can be distinguished, perhaps even the fingerprints of alien photosynthesis. The silence may break further, unfolding into confirmation. But even before that, the philosophical shift is complete. The universe is no longer merely the stage for life. It is itself alive. And so the story closes where it began, with Webb's golden mirrors, tilted toward eternity, catching the faintest breath of distant suns. They do not only collect light, they collect meaning. They gather whispers too faint for ancient eyes, transform them into stories too vast for ancient minds. They reveal that the silence humanity feared was never true silence. It was anticipation, the long pause before the music begins. Perhaps in time, contact will follow. Not only detection of life, but recognition of minds. Perhaps communication will be forged across impossible gulfs, or perhaps it will not. Perhaps the other worlds will remain unreachable, their songs never shared, their histories never known. But even if that is so, even if humanity remains forever distant from its cosmic kin, the mirror is already enough. To know that life is not singular is to know that existence is richer than once believed. To see another breath is to realize that the universe itself is capable of dreaming. And in that realization, humanity is both humbled and exalted, smaller in scale, yet greater in meaning. For in searching outward, it has found inward. In looking for the alien, it has rediscovered itself. The breath between stars continues, unseen, unheard, unmeasured. But through mirrors of gold and minds of wonder, humanity has finally begun to listen, fade to silence, fade to light.